Well, welcome to the second part of our lesson on rational expressions. In this lesson, we are going to talk about adding and subtracting rational expressions and also how to simplify complex fractions. So let's start right off talking about what we mean when we talk about a rational expression. And rational expressions are basically just fractions that have algebraic expressions in them. And they follow the same rules as any other fraction for adding or subtracting them. So the first thing you're always going to do is to find a common denominator. And the best one to use is the least common denominator because then you won't have to simplify in the end. So that's going to require us sometimes to find equivalent fractions. So here's our first example. If we want to add these two fractions, we need to get like denominators. And one denominator has an x and the other has a y. So our common denominator will be x times y. So this first fraction on the left, we need to get an equivalent fraction. So what we need to do is multiply that by y over y. That's the same as multiplying by 1. And on the right-hand side, we need to find a common denominator there of xy. So that will need to be multiplied by x over x. So now we can actually just go ahead and multiply across. We'll get 5y over xy plus 6x over xy. And once we get that, we can actually add those together and we end up with, sorry about this, I'm having a little trouble with that. We end up getting 6x plus 5y over xy. Now, they switch the order of these. Remember, the commutative property allows us to switch the order. So usually we write those alphabetically. So the term that comes first in the alphabet, you're going to write first in your answer. Here's another example. Sometimes it might require you to factor before you go ahead and find your common denominator. So in this example, the denominator here is a trinomial, but this trinomial factors into two binomials, and this is actually a perfect square trinomial. Factors of 4 that add to 4 are 2 and 2. This tells us the signs are the same and they are both positive. So this we could have written as x plus 2 the quantity squared. Over on the right-hand side, we have a difference of two perfect squares. X and x are our first terms. Factors of 4 are 2 and 2. And there's no middle term. This is just a binomial, so that tells us one of the signs is plus and one of the signs is minus. So now we need to find our common denominator. Well, they share a factor of x plus 2 is already there. But I need to have at least two of those. This one has 2x plus 2's. So our common denominator will be x plus 2 the quantity squared. But then I also need an x minus 2. Okay, so that's going to be our common denominator. So up on the top left here, this one is missing the x minus 2. So I'm going to multiply the top and bottom by x minus 2 over x minus 2. And then over on the right-hand side, that one needs to be multiplied by a factor of x plus 2. It's just missing one of those factors. Okay? So my numerator then, on the left-hand side, distributing the 6 times the x minus 2, I end up with a 6x minus 12. And then I'm going to put a minus sign here, and I'm going to use a parenthesis. I'm going to multiply this 2 times the x plus 2. So that gives me a 2x plus 4. And now I can go ahead and write my numerator, distributing this negative through the parenthesis. I get a 6x minus 2x, which leaves me with 4x. I have a minus 12 minus 4, which is a minus 16. And you can see that I'm going to need to go ahead and factor that numerator as well. I'm just going to rewrite my denominator, x plus 2, the quantity squared, and an x minus 2. And then factoring the numerator, I can take out a 4, and I end up with an x minus 4. And then rewriting my denominator, I will have this written then in fully factored form. And it doesn't look like there's anything that will cancel between my numerator and denominator, so that's my final answer. All right, I've left one on this page for you to try on your own. Make sure that you work on this one, and I'll talk about that in class. Please remind me to give you the answer to that in class. So, simplifying complex rational expressions. Okay, a complex rational expression is basically just a fraction with a fraction in it. So what we're going to do to simplify these is we're going to focus on either the numerator or the denominator first and get that simplified. And then we're going to end up changing our division to multiplication and flipping the denominator. So let's focus here on the numerator first, since it has two terms that are added. So we need to find a common denominator. This is like y over 1. So my common denominator will just be x. So I don't need to do anything with the 1 over x, but I need to multiply the y by x over x. When I do that, I get xy over x plus 1 over x. And then I can add my numerators, xy plus 1 over x. So this is just the numerator simplified. Okay, so now what I'm going to do is I'm going to go ahead and take that and I'm going to multiply by the reciprocal of the denominator. Here it's written with the fraction bar in it. Excuse me. So now I'm going to change that division to multiplication, and then I flip the denominator, and that gives me a y times xy plus 1 all over x squared, and that's your final answer. There's nothing that simplifies there. That's it for this video. Pretty short one for you. Here's your lesson check. Please do these problems before you come to class tomorrow. See you next time.